Hey everybody, Mr. Quick here, looking at Eureka Math / Engage New York Math, Module 2, Lesson 4, and today we're going to be dividing fractions by fractions, looking at some different models. And one of the models I'm going to look at today involves equivalent fractions. And if you recall, equivalent fractions look something like this. Let's say we have 2/3. Well, we know if we use our constant or magic number, as I always like to say, and we want to multiply that by 2. Of course, you multiply the numerator and denominator both by 2, you would have 4/6. 2/3 and 4/6 are both equivalent. If you wanted to use a different number, you could multiply it by 3, and you would end up with 2 times 3 being 6, 3 times 3 being 9, 6/9 is equivalent to 2/3, 4 and 4/6. All three of those fractions are similar. If you wanted to go the other direction and actually use division, in this case you can't do it because this is in simplest form. But if I gave you 10/12 and you wanted to divide both of those by 2, you'd get 10 divided by 2 is 5, 12 divided by 2 is 6, and you would get 5/6 being equivalent to 10/12 and also being simplest form. Okay, let's jump into some examples. Okay, let's look at this example. Molly's friend Xavier has 11/8 cups of strawberries. He needs 3/4 of a cup of strawberries to make a batch of tarts. How many batches can he make? Well, one of the key tenets of this lesson is recognizing that when we have 11/8, which we're going to then divide into 3/4, they don't have a common, or they don't have the same denominator, but they do have a common denominator. So I can change both of these denominators into eighths. 11/8 would obviously stay the same. If I use magic number of times 2, 3 times 2 is 6, 4 times 2 is 8, and now we have 11/8 divided by 6/8. If we can get to a point where we're dividing and we have common denominators, this can eliminate itself, and what you end up with is 11 divided by 6, which is the same as 11/6. 6 goes into 11 one time, which would equal 6. From 6 to get to 11, counting up, 6, 7, 8, 9, 10, 11. You have 5 left over. Denominator stays the same. He can make 1 and 5/6 batches. Let's look at a visual model of that. First, I'm going to create 11/8. And to do that, I need 8/8, right? 1, 2, 3, 4, 5, 6, 7, and 8. That is 8/8, meaning that is 1. But I know I need 11/8, so what I'm going to do is I'm going to switch to a different color to know that I'm now extending beyond my 1 whole. That is 1 whole. 9/8, 10/8, 11/8. If I need to, I can go farther, right? Let's go 12/8. So actually, let's do that. We'll do that with a different color entirely, right? So I know that this whole thing right here is my 11/8, okay? Since I made my 3/4 into 6/8, I'll use orange for that, I know I can go 1, 2, 3, 4, 5, 6, and that's one set of 6/8. If I continue, I go 1, 2, 3, 4, 5, 6. I know my 11/8 ends right here, so that means right here I have one set of 6/8, and then of what is remaining, we have 1, 2, 3, 4, 5, and there's a 6 that we don't get to, right? Because while the 6/8 that we have here does go that far, our 11/8 stops here. So that's kind of two ways to look at that. All right, let's try another example. Okay, the example here is 3/4 divided by 2/3, and it wants to know what is the question asking. So it could either be 2/3 of what is 3/4, or how many 2/3 are in 3/4. So something we can do here, we can do two things. We can do many things, much more than two. We could do the keep, change, flip, keep 3/4 the same, change division into multiplication, and flip 2/3 into 3 over 2. 3 times 3 is 9. 4 times 2 is 8. We have 8/9. 8 goes into 9 one time, which equals 8. There's 1 left over to get to 9. Denominator stays the same. We have 1 and 1/8. That's one way to do it. Here's another way. I'm going to leave this answer over here in red, and I'm going to write the next part of the problem in green so we can see if our answer is the same. So we have 3/4 divided by 2/3. I recognize that 3 and 4 are going to are both factors of 12, right? So they can be multiplied together. So if I want to make my denominator the same, it means I want to make them both 12, right? 4, 8, 12, 3, 6, 9, 12. That's the least common multiple. So to get from 4 to 12, I have to multiply by 3, which means I also have to do 3 times 3, which is 9. Over here, I've got to multiply by 4. 3 times 4 is 12. 2 times 4 is 8. And I end up with 9/12 divided by 8/12. As we said before, we're dividing, and the denominators are the same, so I can just erase that part, and I know that I'm dividing 9 divided by 8, which is the same as 9/8, which is the same as 1 and 1/8. Okay, so a couple different ways to do that, but if you'll notice, hey, we ended up in the same place, right? That's the great thing about math. There's so many different ways to get to the answer. Don't let anyone tell you there's just one way, right? You do what's comfortable for you. Okay, let's look at a couple more examples. I'm going to do this one as a keep, change, flip. Keep, change, flip. So 6/2 divided by 3/4. I'm going to keep 6/2 the same. I'm going to change division into multiplication. I'm going to flip 3/4 and make it 4/3, and I'm going to multiply straight across. 6 times 4 is 24. 2 times 3 is 6. And I know that 6 goes into 24 evenly. 6, 12, 18, 24, 4 times. There's nothing, in this case, nothing left over. So we end up with, our answer just is 4. This one we'll use a common denominator. 7/8 divided by 1/2. I can recognize that 2 goes into 8 evenly, so I'm going to keep this 7/8 the same, divided by, I want this to be 8 as well because I want a common denominator. 2 to get to 8 is going to be times 4. That means I'm also going to do 1 times 4, which is 4. I see division. I see the same denominator, so I can ignore that. And I can do 7 divided by 4, or, which is the same as 7/4. 4 goes into 7 one time. There would be 3 left over. Denominator stays the same, right? 1 and 3/4. Okay, this is the last one, and on this one I'm going to do a visual model. So we'll do it in black here. Okay, 4 and 3. I recognize that I can turn both of those into 12, right? So, and if I didn't know that, what I would do is I would write them down like this. And I would say 4, 8, I'm just doing multiples, 12, 16, okay. 3, I would go 3, 6, 9, 12, and hey, 12 is the first number I come to. So I'm going to go with 12. If I needed to write more numbers, then I would just keep going. All right, so 4 times 3 and 3 times 4 is going to get me to 12. I got to do the same thing up top. 5 times 3 is 15. 1 times 4 is 4. So I end up with, now I have the same denominator, 15/12 divided by 4/12. And so what I'm going to do right now is I'm going to create a model. I'm going to pause the video so I can create that because that'll take a minute. So you'll see, the next thing you'll see is that model popping up. All right, I'm going to unpause here. I've created my model. I start at 0. And I went all the way to 15/12. Actually, technically, right here I went to 16/12, but that's okay. I could keep going. I could go as far as I want, right? But I need to have at least the 15/12 because that's what we're going to cut up. So this is, you'll notice that right here, mark that in red because that would actually be the number 1, right? 12/12 is 1 whole, okay? So, but I'm going to divide it into 4/12. So I'm going to start with 0, and I'm going to say 1, 2, 3, 4. So that's 1 set of 4/12. 1, 2, 3, 4. That's one set of 4/12. 1, 2, 3, 4. That's one set of 4/12. 1, 2, 3. Now, I could keep going, but I don't need to because 15/12 is where I'm going to stop. So that is 3/4 of my next set, right? I only went 3 instead of going 4. So if you'll notice, 1, 2, 3 holes, 3/4 would be my my answer there. Okay, so just to double check that, let me erase all of that good stuff, or most of it anyway, and let's test it the other way. Let's do 5/4. Let's do keep, change, flip. Times 3/1. 5 times 3 is 15. 4 times 1 is 4. 4 goes into 15. 4, 8, 12. 3 times. 12 to get to 15 is 3 left over. Denominator stays the same. 3 3/4, 3 3/4. Good to go. All right, that's all I have for you. I know that those are different examples and I went pretty quickly, but that's the beauty of video. You can go back, rewind, watch, pause, all that good stuff. You can also ask me any questions that you may have in class. Okay, thank you for watching. I'll see you soon.